Hi tech family, welcome to eTechViral. We have started course of the Solidity programming language. We will cover all the fundamentals of the Solidity language in this course, and we will also build a lottery application at last. So if you are fully beginner, most welcome to this course because we are going to cover all the things from scratch. Alright, first let me introduce you to the Solidity programming language. Solidity is object-oriented programming language. Using Solidity, we write the smart contracts. These smart contracts are the programs which govern the behavior of the accounts within the Ethereum stack. How it governs the behavior of the accounts within Ethereum stack, everything will be clear to you later in this course. You may be seen or heard, everyone says the language Solidity looks like JavaScript. However, it's neither, because JavaScript runs on a browser, it modifies mutable or we can say changeable data structures. Like anytime when you made mistake, you can easily go back and repair your data. But in case of blockchain, I'm saying blockchain just because when a smart contract deployed, it runs on thousands of nodes that has peer-to-peer connection with each other. Like you cannot do anything here and cannot make any changes in here. You have to write quality code for that. We are going to cover many topics in this course, but first we will look at the IDE of the Solidity because that's most important step, and then we will explore the IDE. The topics we are going to cover are state variables, functions, the function modifiers, data types, events, errors, and the transfer between different accounts. These are the topics to cover, but let's not think we are gonna have only 7 videos in place. We are gonna have many videos of these topics because every topic has its subtopic and we will make separate videos on these topics and their subtopics. I'm very excited to teach you all these things in the latest version of the Solidity. Hi tech family, welcome to the second part of the Solidity programming language course. Now we are going to explore the Remix IDE, where we write our Solidity code and our smart contract. You have to go to your browser and simply type Remix IDE, and then you will find this Remix Ethereum IDE with the domain https remixethereum.org. Simply click on this and this window will appear in front of you. You have to close this home because there is nothing special in this home, and that's our editor where we write our Solidity code. First we will explore this part. You will see the workspace here. I have the workspace of named workspace 2. Workspace is something like a project. Like in any other frameworks we have projects. Here you will see the option create. From here we can create the new workspace like the new project to work on it. I already have the workspace and there is another option rename. From here we can rename the workspace. Like I rename it from workspace 2 to workspace 3 and then press the OK. And we have now the workspace 3, and from here we can delete our workspace. And that was it for the workspace, and here you will see also the 4 options. The first option is for creating a new file in our IDE. When you press it and then type a name, my file.sol. Sol is the extension for the Solidity programming language. Like when we create the Solidity file, we have to write this extension in front of every file and then press enter, and we got the file of Solidity. That's how we create file in our workspace. And there is another option, create new folder. Here we create the folders like we already have the folders contract, scripts and tests. We can create the folders like them. Like I am creating a folder company work. All the company work will goes here. Like this we create the folders in our Remix IDE. And there is another option which is GitHub. Push all the current workspace file to the GitHub. From here, you can push all your files in the workspace to your GitHub repository. And there is another option of load local file into current workspace, like to upload files from your computer storage to the Remix IDE and in that particular workspace. There are some folders which are the contracts, scripts and the test. Here will goes our contracts files, and the scripts are, we are not going to touch the scripts in this video, and that will be explained later in this course. And another file is test. We will write test in here in this folder of our particular file. And down here you will see the window. Let me resize it. That's the terminal of the Remix IDE. Like when we do some transaction from one account to another account, all the records and the processings will be appear here. Like the transaction is sending, processing and transaction is successfully completed. All the processes will be appear here. And somehow if you want to clear this terminal, there is an button clear console. When you press it, the console will be cleared. You can again collapse the terminal by pressing these arrows, and you can again open it like this. Before going to the next steps, let me show you some code of the Solidity, like how the Solidity code looks like. So let me go to this folder, so storage.sol. So that's how our Solidity code looks like. First, you have to specify the license identifier, because without this, the Remix IDE will give you a warning to specify this license before compiling. And then you also have to specify the version of the Solidity compiler. That's the version of the Solidity compiler, like greater than or equal to the 0.7.0 and will be less than from 0.9.0. And then the contract storage. If you have used other programming languages in the past, you may be familiar with this syntax, like we had class and something like storage and function methods like this. But in case of Solidity, we have the contract instead of the classes. That's the difference between other programming languages and the Solidity programming language. We will go deep in these writing smart contracts, function and these variables later in this course. And now let's move to the Solidity compiler. If these extensions are not appearing from when you start the Remix IDE, you have to go to this plugin manager and you can activate and deactivate these plugins from here. Again, move to the Solidity compiler. That's the version of our Solidity compiler and the language and YOL. The Remix IDE allow us to use Solidity and the Viper language in this IDE. And that's the version of our Ethereum virtual machine. We will come upon it later in this course. And there are some check buttons. When you check this button, the code will auto-compile. You can see our selected file storage.sol is successfully compiled when we check this auto-compile. And that was our Solidity compiler. From here we can compile our smart contracts and then move to the deploy and run transactions. Here you will see the environments. We will come upon them later in this course. And that's the account, and we have many fake accounts already in here. All have 100 ethers that are fake ethers to test our code and transaction between each them account. And that's the limit of the gas, like when we do transaction between different accounts, how much gas it will take. And our compiled contract is storage, and now from here we can deploy it. The contract is successfully deployed. When you can open it, it will look something like this. That was some of the basic steps I wanted you to know about this before starting the Solidity code and writing the smart contracts in Solidity. Hi Tech family, welcome to the third part of the Solidity programming language course. Now we are going to look at the process of contract compilation, like when the contract gets compiled, what will happen. First, when a smart contract gets compiled, it gives us ABI and the bytecode. What are the ABI and the bytecode in the Remix IDE? We will cover these two steps in this video. First, let me show you some theory of what is ABI and the bytecode, then we will move to the practical. This is our flowchart. When a smart contract gets compiled, it gives us the ABI and the bytecode, and then the bytecode has some instructions that goes to the Ethereum blockchain. First, let's talk about what is ABI. ABI stands for Application Binary Interface, a standard way to interact with contracts in the Ethereum ecosystem, both from outside the blockchain and for contract-to-contract interaction. We can also say that a bridge to interact with outside or inside contracts. Like a company want to interact with our smart contract through the ABI, it can interact with our smart contract. In the practical, I will show you how this ABI looks like. When the smart contract gets compiled, it also gives us this bytecode and is also called EVM bytecode, means Ethereum Virtual Machine, which gets deployed on the Ethereum blockchain. As I said earlier, this is quite similar to the Java language where the code gets converted into JVM bytecode, Java Virtual Machine bytecode. And there are some instructions in this bytecode which goes to the EVM and it works on it. Let me tell you one more thing that you must have to know. Whenever a smart contract gets compiled and deployed, the only bytecode runs on the Ethereum blockchain but not the whole smart contract. You must have to remember this, remind it or write it down in the paper so that you will not forget it. Now let's move to the practical. Alright, that's our Remix IDE. I will go to the contracts and I want to compile first this storage file. You can compile any of these, but in my case, I want to compile this. There is a smart contract written in the Solidity. I have to go to the Solidity compiler, and as I check this box auto compile in the previous video, if you didn't watch it, go and check out the previous video. I have checked this box so that my file gets auto compiled, and down here if you see ABI and the bytecode. First I will show you the format of the ABI. So I will copy this ABI and go to an editor and paste it here. That is in the JSON format. That's how our ABI format looks like. Inputs, name, retrieve, and some uint 256, name and type, state mutability, view. So let's see, are there a function retrieve and these view type state and this state mutability view. Again go to the Remix IDE, and yes, we have this retrieve function and the state mutability that view the uint 256 number, and that's all. Again, that's like a bridge to interact with other smart contracts. And next we have this bytecode. So let's also check how this bytecode looks like. Also copy this and go to the editor and paste it right there. It's also in the JSON format, key and value pairs, but that is our bytecode, and that OP codes is its encoded format. If you didn't believe me, let me show you. I will copy this bytecode which is in the value of this object key. I will copy this and go to a website etherscan.io, convert bytecode to OP code. First it says enter contract bytecode. First we have to type OX and then paste our bytecode, and here you will see a button decode and our code is encoded. You can see push 0x80 push and all the instructions where we already have in here. Push 1 and DUP, call value, push 2 and many more. And that was our bytecode. That was some important information about the Solidity and that the Remix IDE. That was some important information you must have to know about this before go and start coding in the Solidity. Hi Tech family, welcome to the part 4 of Solidity programming language course. Now we are going to learn the difference between the mainnet and the testnet. The basic difference between the mainnet and the testnet is that the testnet only exists as a working prototype for a blockchain project, while a mainnet is a completely developed blockchain platform for users to send and receive cryptocurrency transactions. That was just the basic difference between mainnet and testnet. We will go in more depth while seeing the table of difference between mainnet and testnet. We have this table in place. Difference between mainnet and testnet. The first step of mainnet is real value transaction take place. So what does it means? I will tell you the full mechanism of this. That how real value transaction take place in mainnet. A developer write a smart contract in the Solidity language and then compile it. Alright, so the developer will deploy it. There will be some method in the smart contracts like sending coins, receiving coins, and some other methods for the transaction. Now, when this transaction takes place, a real value transaction will take place. It means when I want to transfer some money to my friend's account, so the money take place in this transaction will be the real money or some real ether, and that will not be like the banking system, but that transaction will be done through the Ethereum wallet. And here instead of money we have the ethers, and that was the first step of the mainnet. And now let's move to the first step of the test network. Fake value transaction take place just for testing purposes. As I told you the mechanism of the mainnet, same goes for this. The developer write a contract and there will be some methods for sending and receiving and many other methods, and before deploying it to the mainnet, the developer will test it on the test network, and there we will have some fake accounts and some fake ethers to do transaction between these accounts and test our contract, and then the developer will deploy it on the main network. That was just the simple difference between these first steps of the mainnet and the testnet. And then let's move to the second step, paid using native coins. That's similar to the first step, like the real value transaction takes place. When you do transaction, the money or the ether, that will be in real form, but in case of test network, that will be free. It gives us free ethers to do transaction just for testing purpose. And the two steps has done of the mainnet and testnet. And now let's move to the third step, economic incentive to earn real coins. Like we can do mining in the cryptocurrency network, we can invest our money and then we also can earn it, and sometimes we also can lose the money. It depends on the market, it's go ups and down. And the third step of the test network is no economic benefits. Like any transaction take place in the test network will be fake transaction and there will be no economic benefits. We cannot earn it from the test network. That will be only just for testing purposes and mostly used by developers to test their smart contracts. Are they working fine or not? If it's working fine, so they will deploy it on the main network. Just like that simple. And the fourth step is example are Ethereum mainnet. The Ethereum mainnet is the example of this main network, and the example of this testnet is Ringb and Robston networks. I will show you these mainnet and these test networks in the next video of the MetaMask. MetaMask is a cryptocurrency wallet from where we can do transaction between our accounts. And the fifth step is mainnet ID is 1 and the testnet ID is 2342 etc. So what does it mean? To clear your confusion about the mainnet ID is 1 and testnet ID is 2342 etc., I have an image to show you. That's the image when a new node wants to enter the chain of the many nodes. So if it want to enter the main network, so it ID must have 1. As I said in here, mainnet ID is equal to 1, and if it want to enter the Robston, Ringb and many other test networks, its ID will be 3, 4 or something. So that will be the part of the test network, and for the mainnet its ID will be 1. These was some steps of the difference between mainnet and testnet. I hope I have cleared to you the difference between main network and the test network. Hi Tech family, welcome to the part 5 of Solidity programming language course. Now we are going to talk about the most important topic, which is Solidity stat variables. We will look at some types, how we can declare variables, how can we initialize variables, and there are how many ways to initialize our variables in Solidity, and we will see how we can work with these variables. So stick with us and let's move to the IDE. We are on the home page. First, let's close this home page, and here in the smart contracts folder, we will create a file. Let's say I will name it stat variable.sol, mean the solidity file. And now we are in our solidity file stat variable.sol. In the first line, we have to specify our license identifier, otherwise the compiler will not be happy. So let's see how we can specify the license identifier. You have to put /spdx license identifier column and MIT. That's how we specify our license identifier to make our compiler happy. And then we also have to specify the version of our compiler. So for that we will write pragma solidity version will be greater than or equal to 0.7.0 and will be less than 0.9.0, and that's it. And now we will start creating our smart contract. For that we will write contract, and the name of our contract will be stat, let's say only stat, and we will open the body, open and close brackets, and inside the body we will declare our variables. To declare variables, as Solidity is a statically typed language, so first we have to specify the type of our variable. That will be uint. Uint mean unsigned integer. As this is an integer type, so we will name it salary. Salary is also a number, so something like this we can declare our variable. And then let's go to the compiler. We have the compiler version, and let's compile it. It's successfully compiled. It gave us ABI and the bytecode, and now we are going to deploy it. So let's move to the deploy and run transaction, and then look at the account. We have this account and 100 ethers. When we deploy our contract, so that much gas it will take, and this will minus some ether from our account. So let's see, we are deploy our contract. In the terminal you can see something is successed, and by charging that much gas it minus some ether from our account. You can see 99.999 and so on. That's 99 is just because of their unit is way, that's why it's like this, and it minus some ether from our account. And now we have this instance of our smart contract, but we are not able to see anything in our smart contract. As this is a stat variable, this should be able to visible here, but it's not. Let me tell you why it's not showing here. Just because we have not make it public yet. So make it public, and then again go and compile it. Let me tell you one more thing. The Solidity code work on compile time. Like, it's not dynamically typed language, it's the statically typed language, and its code work on compile time. Like the instance, that instance will not be changed. Like when I directly change this public and press Ctrl S, and this will become a public. This will not like this. For that I have to compile it and deploy it again. So there will be another instance of this particular stat, and then we will be able to work with that. That's simple. And now let's again deploy it, and some transaction is successful, and you can see that's our previous contract deployed. There is nothing, and let's close it, and we have this another smart contract. Open it, and now we have this salary because we make it public. So what this public means? Public means when we public our salary means our variable, so it makes a getter method for it. So now that's a getter. In the Solidity programming language, we don't have the null variables. Like in C we have null, and in Python we have none. variables when we declare it directly. But in case of Solidity, there will be some value in the variable even when we have not initialized it yet, but there will be some value in it. To see where the value of this salary is, simply press on this salary and you can see there is a zero value even though we have not initialized it yet. And the next is how we can initialize this variable. If you're familiar with any other programming languages, like when we declare the variable like this, we can simply initialize it like this. Like we type the salary again and equal to the value will be 3000. Like this, we can initialize our variables in other programming languages. So let's compile it and see is that correct or not. It says the parser error expected identifier but got equal to. That's the wrong way to initialize variables in our Solidity programming language. We cannot initialize variables like this in our Solidity programming languages. There are about 3 ways to initialize variables in the Solidity programming language. You simply have to remove it, and the first way is direct make it equal to 3000 and compile it, and that's correct. Again go, close this and deploy it. Now we have the third instance, salary is 3000. That's the first way to initialize variable, and the second way is, let's remove this. We can initialize this variable in our constructor. I will tell you what is constructor in the later videos, but first let's see we can initialize the variable in our constructor. We will make it like this, salary will be equal to 5000, and that's great. Again compile it. There is an error, function variable struct or modifier. Oh, my mistake, I passed it contract again, but that's not the contract but a constructor. Sorry about that, it's my bad. And again compile it, and now that's great. And then again move to the deploy and run transaction, close this one, deploy it. The fourth instance is 5000. That's great. And the third way is simply we can make a setter to set this salary value to some integer value like this. So let's see how we can do this. Remove this constructor and make a function. Name will be set salary, and that will be a public function. Open its body, and salary will be equal to let's say 6000. And that's also a good way to initialize our variables in Solidity. Again let's compile it and close this one and deploy it. The fifth instance, we have, first let's check the salary. In the first step, when we check the salary, we have 0 salary. When we press this set salary and then again check the salary, now we have the 6000 salary after calling this set salary function. That's how we can initialize stat variables in our Solidity programming language. And again, I'm telling you, when you initialize a variable like this in your contract, that takes some storage in your contract, and when you deploy it, it charges some gas. So be careful in this case when you declare your variables in contract. That was a simple way just to show you how can we declare and initialize the stat variables. Hi Tech family, welcome to the part 6 of Solidity programming language course. Now we are gonna learn what are local variables in Solidity and how can we work with them. So we are not going to do anything in this PPT. Let's move to our Remix IDE. So we are now on our Remix IDE, and that's our previous file. We talk about the stat variables. You can see I have commented some of them, and one is uncommented function set salary. We have covered the stat variables, and in this video we are going to learn what are local variables. So for that I will create a new file. I will name it simply local variable.sol. So first thing we have to do is we have to specify the license identifier, and the second is that version of the compiler. So I will simply go the stat variables folder and copy them and simply paste them here, and that's it. And now let's create our contract, and the name of the contract will be local variables. Let's first create a stat variable uint public age. That's our stat variable, but the local variables will be inside a function. So for that, let me create a function. Name will be place of local varies. I make it pair just because the pair function does not read or modify the variables of the stat. It can only use local variables that are declared in the function and the arguments that are passed to the function to return some value. So by doing this, we have completely finished the interaction of this function with this stat variable. And then we will make it public to make it visible when we deploy our contract. And then this will returns uint and body. Inside this, we will create local variable. Let's say I create uint of named salary will be equal to 3000, and this will return the salary. After this, let me compile it, and there is an error. Declaration error, identifier not found or not unique. Just because we put it unit instead of uint. Oh, that was my fault, sorry about that. And then again compile it, and that's great. Go and deploy it. We got our contract. There are age, which is 0 because we have not initialized it, and then place of local varies. There is a local variable having the value of 3000. So you may be wondering, I have used two returns. One is returns, and the parentheses I have passed the uint type, and one is only single return which returns the salary. The difference between them is, if you have familiar with the other programming languages, or simply I can say a Dart language, when we create functions we specify the return type of the function. So that's simply the return type of the function, and this is returning a uint, as simple as that. And let's declare one more variable upon this, that would be string, and name of employee will be equal to some like, let's see, John, and semicolon. Let's again compile it. There is again an error. The data location must be storage or memory. That's because the string variable by default used as a stat variable, and they take some of the storage from our contract. So to use it inside the function like a local variable as a local variable, so we have to put another keyword which is memory, so this will not throw any errors after we compile it. And that's great. It's there is a warning unused local variable just because we have not used it, so that's why there is a warning. So like this, we can use the string stat variable as a local variable. And there are some more data types like struct types, enum, and other. Hi tech family, welcome to the part 7 of Solidity programming language course. Now we are gonna learn the view and pair functions of Solidity programming language. We will see how can we work with these functions. So without wasting our time, let's move to the Remix IDE. And we are back with our Remix IDE. First, let's close this home, and we have already these two files, stat variables and local variables, and we are going to use these stat variables and local variables in this video. If you don't know about them, I already have created videos on these topics, so please go and check them out. So let's start creating a file. The name will be view and pair.sol, and first thing we need is the identifier and the version of the compiler. So I will simply copy it from this file and paste it here. And the next is simply create a contract, and the name of the contract will be pair and view. First, we are going to talk about what are view functions in Solidity. view functions are read-only functions, like they do not modify the state variables, but they only can read them, and they also can read their local variables. So let's see how can we work with them. Let's start creating state variable, state var, and down here there will be our uint type age. We have declared this state variable, and now we will start creating a view function. To create a function, we have to type a keyword which is function, and the name of the function will be get view function, and we will set its visibility to public. What are the visibility in Solidity? We will talk about this visibility topic later in this course. There are some visibility keywords like private, public, external and internal, but we are not going to talk about in this video. We will explore them later in this course. And this public means just to visible it when we deploy our contract, and this will also be visible at the outside world, like anyone can see it. And then we will make it view to read some data, and it returns uint, and the body, this will simply return age, and that's it. Let's go and compile it. There is an error return. Oh, we have to pass returns here because this will be the return type, so we don't have to pass the return here. This will be returns. Again, compile it, and it works. And now the next step is to deploy it. Go and deploy it, and we got the instance of our contract. If we get it, it has 0 value because we have not initialized it yet. Okay, first let's initialize it. Age will be 30, and again compile it and deploy. We have now the second instance. Get it, and now it has the value of 30. So that's how we get the state variables through this view function, and that is only read-only function. It also can return its local variable. Like, let's first remove this age and create some local variable. Like, I am creating string. It will be the local variable, so I will make it memory. Memory means it will be temporarily stored. It will not take any space in the contract. So string memory, and the name of the variable will be person equal to John. That's our local variable. I typed the memory in front of string because by default that string is a state variable. So to make it a local variable or use it as a local variable, we have to make it like this, memory, and now that is a local variable. And now let's return this person, and this will throw an error just because its return type is uint. So let's also change it to string memory because it's returning the string memory. And now again compile it and go and deploy it. In the third instance, if we press this get view function, we got the John, and that's how we also can get our local variables through this view function. And let's move to the Payable function. How this Payable function works. The Payable function neither modified nor read the data of the state variables. The Payable function only can read the data of the parameters you pass in its parentheses, and only the local variable present in this particular function. So let's start also creating this. The function get Payable function, and this will also be public, and this will be not here, public and Payable, and this will be also like the get view function returns. Like, I passed uint sum, it will return uint sum, open its body, and here I will create two local variables which will be of type uint unsigned integer. Number 1 will be equal to 100 and number 2 will be equal to 3000, and that's not the unit but uint. And sum will be equal to number 1 plus number 2, and return the sum. And that's it. Let's move to the compiler and compile our code and close this one and deploy it. We have the fourth instance, get Payable function, let's get it, and we got 3100, the sum of these two local variables. And now when we get this view function, it gives us the John, that local variable. Just for checking purpose, let me return this stat variable in this Payable function. Let's see what will happen. Let's return this edge and comment out these three variables and go compile it, and we got an error. The function declared as a Payable but its expression reads and blah blah. It says the edge variable is a stat variable, and as I told you, the stat variable cannot be returned from this Payable function. So let's uncomment them and again return the sum. Again move to the compiler and compile it, deploy, and in the fifth instance we got again the same answer. So in the ending, let me again tell you the view and the Payable function. Just for the quick recap, the view functions are just the read-only function, like we only can read the stat variables and the local variables and the parameters passed in its parentheses. And in the Payable functions, we neither read or nor modify the data of the stat variable, but it will only use the local variables and the parameters passed in its parentheses. That's the difference between that Payable and the view function. And we also have explored one more thing in this video, that memory keyword. That memory keyword is just to make it temporary, because this will not take any place in the contract, but this will be temporary. And we are using the string data type as a local variable. By default it's stat data type, but we are using it as a local data type, so we also have to make it temporary by writing this memory in front of it. And that's it. Hi Tech family, welcome to the part 8 of Solidity programming language course, and now we are going to explore what are the getter and setter functions in Solidity programming language. Okay, so let's move to this Remix IDE and close this home, open this contracts, and we will create a new file for that. I will name it getters and setters.sol. And the first thing we need is this identifier and the version of the compiler. I have copied it from the other file and pasted it right there, and then create a contract, and the name of the contract will be getters and setters. First, let's create a stat variable which will be of type string company equal to Google. That's our stat variable. So to get its value, we have to create a function for it. That will be a getter function. And we also have learned about this getter function in the previous video. That will be a simple view function, like a function, and name will be getter, visibility will be public, and just to read that stat variable, return type will be string, memory, and simply return this company. And that's it. Let's go to compiler, compile it, and deploy it. If you press this getter function, and we got the Google value. As simple as that. And the next question is how we can set the value of this stat variable. For that, we have to create a setter function. Name will be setter, and that will be public, but that will no more view or Payable. We will just create its body. We will do like write a company equal to Microsoft. Like I am setting this company value, which is Google, to the Microsoft. So let's again compile it and close this first instance and deploy another one. And in the second instance, we have now two methods, which is getter and setter. First, let's check this getter method. Now we have this Google, and when we set this value and again get it, Now we have the Microsoft, just because when we call this setter function, it changed the value of this company stat variable to the Microsoft. As this setter function changes the value of the stat variable. By doing this, it will charge some gas because it's directly changing the value of the stat variable, which is in the blockchain. When we change some value in the blockchain, we have to pay some gas for that. And in this getter method, we are just reading the value of this variable but not changing it. So by calling this getter function, it will not charge any guesses. And let me tell you one more beautiful thing about this public. Let me comment this getter function and simply make this stat variable public. By doing this, this variable will become a getter. Let me show you how. Compile it, and in the third instance we got the company getter. That's because of this public keyword. When we again press this company, we got the Google value the same as the previous, and again set it, and when we again get it, now it's Microsoft. It's same as the previous, so we also can do it like this for the getter function. Hi tech family, welcome to the part 9 of Solidity programming language course, and now we are going to learn about the constructor. What is constructor in Solidity? If you have used any other programming languages in past, you may be familiar with the concept object-oriented programming. A constructor is a special method in this concept, and it gets called when the object of the class is initialized. But in case of Solidity, it also a special kind of function which invokes only once when the contract is deployed and is used to initialize the stat variables of the contract. So let's see how can we work with constructor in Solidity. For that, we have to go to our Remix IDE, open the contract folder. I am going to create a new file in here, and I will name it const.sol. The first thing we need is the version of compiler and the license identifier, and simply create a contract. Learn constructor. Let's say we have a stat variable in place, like I am declaring a variable of type uint person age. I have declared this variable, and let's initialize it in the constructor. To create a constructor, Solidity programming language provides us a keyword which is a constructor. This is special kind of function, so there will be parentheses, open and close brackets, and we will simply do like this: percentage equal to 40, and that's it. And also, to make it visible when we deploy our contract, we also have to make it public and then compile it. Go and just deploy it. We have this instance of the contract person age. When I press it, we got the 40 value, and that's how we initialize the stat variables in our constructor, and this constructor will invokes only one time when the contract is deployed. And we also can pass some parameters in here, parentheses. Let's say I am passing uint generate age, so the person age will be equal to generate age. And now I again have to compile it and close this one. So now you have to specify the age here with the deploy field. That field will appear whenever we pass some parameters in the constructor parentheses. So that is of type uint, so I will pass 20. The age will be 20. Now deploy it. We got the second instance, and when I press this person age, we got the 20 value. The value we passed in here. And that was the constructor in the Solidity. It is also used for many other purposes in the Solidity programming language. That was just the basic use of the constructor, and we will learn more about it when we go dive deep in this course. Hi tech family, welcome to the part 10 of Solidity programming language course. And now we are gonna learn what are integers and their types. First, we will see some theory, then we will move to the practical, and I will show you practically how we can work with different types of integers in Solidity. Now we are on the next slide. We have two types of integers. First is int and the second is uint. This simple int is a simple integer that it can have some signs like positive and negative, and that is unsigned integer. It don't have any signs, like it will be in only positive digits, and they are of various types like int 8, uint 8, int 16, uint 16, int 32 and uint 32. That numbers are nothing but the integers bit, like that one is 8-bit integer and that one is 8-bit uinteger and so on. That are not range from only 32, but they are like uint 8, uint 16, uint 32, uint 64 and uint 256. That are divided in bits. And the next we have the range of these particular integers, like uint 8 has the value of -128 for negative and 127 for positive, and in case of int 16 we have the value of 32,768 for negative and 32,767 for positive. So how we can calculate the values of these bits? There is a formula for that, and the formula is this formula. You can calculate the values of these bits by using this formula. This is for negative and this is for positive, and you will see the n here. The n is nothing but the simple, you have to put that 8 here in case of that int 8, and if that's it int 16, so you have to put 16 here. As simple as that. That was just for integer, and now let's move to the unsigned integer or uint. In case of uint 8, we have the value of from 0 to 255, and in case of uint 16 we have the value of from 0 to that big value, and the formula for that is that integer formula, and that formula look like this. And let me tell you one more thing. In case when we are coding in Solidity and we declare a variable of type int 8 and we pass some value which is greater than that much value, so there will be an overflow error in the compile tab when we compile our code. So now let's move to our Remix IDE. We are on our home screen, so first let's close this home, and like always we will create a new file. I name it integers.sol, and like always again we need the compiler version and the identifier, and now we will start creating our smart contract. Integer types, and let's say we declare a variable uint 8. Let's say I name it a equal to 200, and that's fine because the value of uint 8 is 255. Let me show you. That's the range of uint 8 from 0 to 255. So it's okay to use the values which are before the 255. So we are using 200, its legal value. When we compile it, nothing will happen, and that's the correct code. But what if we use the value which will be greater than 255? Let's say I type 300 and now compile it, and we got an error. Type error. The int constant 300 is not implicitly convertible to the expected type uint 8. It simply means the uint 8 range is from 0 to 255, and we cannot pass the value which is greater than 255, and that will happen with all type of integers. And let's see another example of it, and this time it will be int type 32. I don't know what its value, but let's check what will happen. I name it b equal to, let's say, 5000, and let's comment this one and compile it, and that's the correct value. Let's say I pass some 99 values which is higher than its range, compile it, and it again says the same error we see before. And that was the ranges of the integers, and I also show you how can we get the range of the integer according to their bit. You will find these formulas from the video description. Hi Tech family, welcome to the part 11 of Solidity programming language course. And this time we're gonna learn what are arrays in Solidity programming language. And we will also see what are the types of array. There are two types of array. One is fixed array and second is dynamic array. These are two types of arrays in the Solidity programming language, and we will also see how can we work with them after moving to the Remix IDE. So without wasting our time, let's move to the Remix IDE. Close this home, create new file, arrays sol, copy and paste identifier and the version of compiler and contract, and now we will create an array. But before creating an array, let me tell you what is an array. Array is just a collection data type in which we store our lots of data, like without creating the number 1, number 2, number 3, and then initialize them 3, 2 and 1 like this. To prevent this, we will create an array for them, like a collection for them, and we will store them in the array, and that's it. So now let's see how we can create an array in Solidity. First we have to specify the type of an array, and first we will also look at the fixed array. How can we work with the fixed array? So for that, let me comment out fixed array. Down here all the work will be of fixed array. So to declare a fixed array, first we have to specify its type. That will be of type uint, because I want the numbers in my array or a collection, and we have to put the square brackets in here, and here we have to specify the length of our array, that how much items we want to store in our array. So I want to store 5 items in my array, and then we have to specify the visibility. I will public it, and the name of the array will be my arr, and that's how we declare a array. And to initialize it, we have to simply put this equal to, again square brackets, and let me put some value in here, 10, 11, 12, 13 and 14, and that is some value in my fixed array. And that's how we also initialize the fixed array without doing anything. Let's go and compile it. It works, and deploy it. In the first instance, we got my arr and a field in front of this my arr. When we click this, it gives us nothing. First it says specify the index of the item we want to get from this array. So I want to get the number which is on index 1, press it, and we got 11 value. That is on 1 index, because the index of the array starts from 0. That item is on 0 and that is on 1, 2 and respectively. And what if I want to take the item which is on 3, and that is 13, 0, 1, 2 and 3, and that's great. Like this we can get the items from the array by passing the index of the array in here in this field. Let's say, what if I pass give me the item which is on index 6, and we don't have any index 6 because its length is 5 and there are only 5 values in place, and we pass the 6 value, give us the 6 value. When you press it, and it give us nothing because there is no value on the index 6. That will be some kind of exception out of bound error, that we are accessing the array which is out of bound. We can also change the values which are present in the list, or we can say array. For that we will create a method function set arr value, and we will set the value on the particular index. So the index will be of uint index and the uint value. Like on that index we want to store this value. So in this function we will simply say my ARR, and on index that will be equal to value, and we also have to make it public, and that's it. Go and compile it, close this first one and deploy. In the second instance we have now two fields. First, let me get some item from my array. I am getting the item 2, that's 12, and now I want to set some value on this 2 index. So on 2 index I want the 100 value. I set the array, and again if I try to get the item on this second index, we got the 100 value because we set it from here. So that's how we set our array values in our fixed array. That was our fixed array. Now let's move to the dynamic array. What are the dynamics array in Solidity? So again we will comment out the dynamic array, and let's also comment them out because we are not going to work them anymore, and we will create another state variable that will also be of type uint, and this time we will pass the empty array because that will be dynamic. We will push and pop value from it, but in the initial state that will be empty. And now we will also have to specify its visibility. Name will be dynamic ARR, and that's it. That's how we declare the dynamic array, and then compile it, deploy. In the third instance we have this dynamic ARR, and it says pass something in here. When we pass 0, it will give us nothing because that array is not yet created and there is no value in here. So now we will create a function to push some value in our array, and we will also create a method to pop some value from it. Pop means remove some value from that particular array. Let's write a function that will be push. I want to push the uint value. Visibility will be public. Dynamic ARR dot push value, and that's it. Compile it and close this third instance, deploy, and open the fourth instance. Now we have two methods in here. One is of push, one is of getting the dynamic array. First let's try to get it. We have not any items, and if we try 0, we not have any item on this 0 index. And then let's try to push some value in that array. I will push 12, and again when we press this dynamic ARR on 0 index we have the 12 value. That's how we push some value in our dynamic array. Now on the 0 index we have this 12 value in this dynamic array. Like let's say I am pushing 30, and this will be on 1 index. Let's get it. On 1 we have the 30 value, and on 0 we have the 12 value. That's how we push value in our dynamic array. And let's also create a function for pop a value, like remove a value from the array. We will also have to write a function. Let's copy this one and change only name of this function pop, and this will not get any arguments, and instead of push we will set it pop and remove this value from inside, and that's it. Close this one, compile and deploy another one. And in the fifth instance we have now 3 functions. First let's check it. We have nothing. I am pushing some value 33, push, and also push 12. Let's check it. On 0 index we have 33, and on 1 index we have 12 value. And let's try to pop. 1 value is popped, and when I check 1 we got nothing. You can see the 12 is not changing because we don't have any value on the 1 index. Let's again pop it and check on the 0. We had 33 value on 0, but you can see we are not getting the value on 0 just because there are no more values in this array because we have popped it or we have removed it from this array. Let me resize this terminal and again press this pop. You can see it gives us and error the value is 0, so we cannot pop any values from here because that's already 0. So like this we can write the push and pop functions for the array, and we also can do this stuff with our fixed array. And let me show you one more thing before ending this video. Let me comment out this dynamic array, and we have the fixed length of this array, and when we pass some more value in here like this, and when we compile it, this will throw an error because that's the fixed length of the array. We cannot pass the value which is up to 5. The value present in the fixed array will be according to the length we pass in here, and we also can determine its length like this. Let's create a function for it. Function get length, that will be public, and view, because we are getting only the length of the array as this is a stat variable, or we can say a stat array, and returns the uint because the type of the array is uint. Return the my_arr.length, and just like this go and compile it, deploy, and when we press this get length, we got the 5 value, and the length of this array is 5, and that's great. Like this we can get the length of the array. There is the big difference between length and the index. The length start from 1, like 1 2 3 4 5, and the index start from 0. And that's it. I hope I have cleared everything to you. Hi Tech family, welcome to the part 12 of Solidity programming language course, and let's learn what is byte array in Solidity. We have learned about the fixed array and the dynamic array in the previous video, and in this video we will learn about the fixed sized byte array and dynamic sized byte array. Before starting coding, first you have to know about some important steps. These are the important steps you must have to know about. In 1 byte we have 8 bits, and in 1 hexadecimal value we have 8 bits, and all the values stored in byte array will be in the form of hexadecimal. To see the practical, let's move to the Remix IDE. I have set up everything. First I have specified the license identifier and the compiler version, and I have created a simple contract named of byte arrays, and now we will start working with our byte arrays. We will look at the fixed sized byte array, how we can work with fixed sized byte array. Let me comment out first fixed sized byte array. To create fixed sized byte array, Solidity give us bytes, and in front of these bytes there are numbers range from 1 to 32, like bytes 1 2 3 4 and 32, but we cannot pass 33. That will be the wrong syntax because there is no array of byte 33. So we will create a byte array of byte 2, or let's say byte 4. We can say that's the type of the array, like the byte array, and we are not going to pass any square brackets because that's not the syntax for the byte array. And now we will put the visibility. The visibility will be public and the name of our byte array. Let's say I name it my byte array. Just like this. We have declared our fixed sized byte array. Press Ctrl S to compile, and it's successfully compiled. Go to the deploy and run transaction and deploy it. In the instance we have a getter method by my byte arr. When I press it, we got the value 0x and some more zeros instead of getting only 0. But why we get this value instead of 0? Just because, if you remember, I have told you the value stored in the byte array will be in the form of hexadecimal, and that's great. We got the value in the form of hexadecimal, and this 0x means that's the hexadecimal value. And as we have just declared this byte array, we have the 00 in here. We have not value in this byte array. To set some value in this byte array, for that we will create a function set byte array. This will be public, and my byte arr will be equal to, let's say, xyz. And that's it. Press Ctrl S. That's the shortcut for compiling our code, and then just deploy it. In the second instance, we have now two methods. One is setByteArray and one is myByteArray. First, let's click this myByteArray. We have the same value as we seen before, and when I press this setByteArray and again press this, we got the 78, 79 and 7a value and again 00. Why is that happening? We didn't get the XYZ value, but we got 78, 79 and 7th. That's weird. Let me tell you why is that happening. Let's move to our ASCII table, and if you can see X, Y and Z. The hex value of X, Y and Z is, for X it is 78 and for Y it's 79 and for Z it's 7th, and that's good value for that. It's just encoded in the hexadecimal value. That's why it's appearing like this, 78, 79 and 7th instead of this XYZ. And as I said, the value stored in the byte array will be in the form of hexadecimal. So it's in the form of hexadecimal, that's why it's not appearing just XYZ but 78, 79 and 7th, the hexa value. And we also can have another number in here. Let's say I pass 6, 7 and again press Ctrl S to compile and deploy it. When I press this my byte array, now we have more zeros in here. Set byte array and again get it. We got 78, 79, 7th and more zeros in here. And if I pass some more value in here, let's say A, B, C, again Ctrl S and deploy. In this instance, set byte array and check it. We got 61, 62 and 63 for ABC. Let's also check it. For A we have the 61 and for B we have 62 and for C we also have 63 value, and that's good. And that's how we work with our fixed sized byte array. And now let's start working with our dynamic sized byte array. Let's comment this out and copy this first comment and make it dynamic sized byte array. To declare dynamic sized byte array, we have to type bytes for that, and then we will specify the visibility, that will be public, and the name of the byte array. Let's say I name it dynamic sized byte and declare it. Press Ctrl S and let's just delete these instances and then deploy. When I check it, dynamic sized byte array, we got only 0x. That's why it's the empty dynamic size byte array and there is no value. First, we have to push some value in it. For that, we will write a method for it or a function push, and the visibility will be public and dynamic size byte dot push, and in the parentheses we will pass the value we want to push. Let's say I want to push again ABC value, semicolon. Press Ctrl S to compile, and there is an error. Let's say why is it says the type error member push not found and visible or not visible after argument dependent. That's because I think, oh I see, we cannot pass 3 values in here, but we have to pass only one value. And for after that, press Ctrl S and now it's correct. Go and deploy it. In the second instance, now we have a push method also. First let's check it. We have 0x, and when I press push and again check it, we have the 61 value, and the hexadecimal value of the A is 61. Let's check it. A 61, and that's good. That's how we push some value in our dynamic byte array, and we also can initialize it like this, equal to xy xyz. Ctrl S, close this one and deploy another one. First check it. We have 78, 79 and 7th as we have initialized it here, and when I press push and again check it, we also got 61 value, and we also can get the value on the particular index. For that, we also have to write a function which will be only a view function, because we are not doing any changes in the state variable but we are only reading it. Function read value, or let's say get value I want to get the uint value that will be public view method returns byte 1 because we are getting only 1 byte, and here we will return dynamic size byte value, and that's it. Press Ctrl S, close this one, deploy, and in third instance we also got the get value. First let's press this dynamic sized. We got this value, the value we have initialized it here, and then push. We got another value which is 61, and now I want to get the value which is on index 2. Get the value that is 7th A 012. This value is on index 2 and we got it 7th A. Just like this we can get the value of dynamic size byte array, and that 0x is just for that's in the form of hexadecimal, and we also can find the length of it by copying this and place it down here. This will be uint, and remove this argument from here, and dynamic size byte will be length, and that's it. Deploy another one. When I press this get value, we got 3. Oh, I have not changed the name of this, so that's okay. We got the length which is 3. 1 2 3. When I put some value and again get it, we have now 4 length. So that's how we can get also the length of our byte array or a dynamic size byte array. So that's how we can work with our byte array. I hope I have cleared your confusion about the byte array. Hi tech family, welcome to the part 13 of Solidity programming language course, and let's learn what are loops and their types in Solidity programming language. If you have used any other programming languages, you may be familiar with the syntax of the loops, that how can we use the loops in programming languages. But if you are beginner in the Solidity, you must have to watch this. In Solidity, we have 3 types of loops: while loop, do while loop, and for loop. And in this video we will see how can we work with these loops. And let me tell you one more thing before going to the Remix IDE. In this video we will iterate our arrays using these loops. So if you have not watched the previous videos, you must have to go and watch these videos of arrays and types of arrays. So after that it will be easy to you how can we work with these loops. And that's it. Let's move to the Remix IDE. And we have done our first step, the identifier and the version of compiler. The contract is also created, learn loops, and now we will start working with loops. First, as I said, I will create an array for that will be of type uint, that will be an fixed array, length will be 4, and this will be public, visibility will be public, and its name will be my array. Just like this I have declared it. I also can initialize it, but when I have declared it like this, so all the values on the indexes will be 0. Let me show you how. Ctrl S to compile. When I deploy it, you can see if I check the value on 0, it's 0, and on 2 index it will be also 0, and on 3 index it will also be 0 because we have just declared it, not initialized it yet. Now we will iterate this array through our while loop and put the values in this array through this loop. To create our loop in Solidity, we have a keyword of while, and then here we will check the condition, and then we need another variable to check the condition. Here I will make it uint range public range, and then I will check the condition when the range is less than my array dot length. So my array on index range will be equal to this range, and then I will increment this variable. You may be thinking what I have done here. It's simple. I have created a variable. There is no concept of null and none in the Solidity programming language. The value of this range will be by default 0, and I have just checked the condition in this while loop while the range is less than this my array length. So my array on index range which will be on first check will be 0. This will be equal to this range, and the range will be incremented when the while loop runs. It will run 4 times because the condition we are checking has 4 length and this range is 0. So first, when the while loop check the condition, it has 0 value, so the 0 is less than the length of my array. So here will be 0 on 0 index will be equal to 0, and then the range will increment it, so now the range has 1 value, and then it will again check the condition. Range, it has 1 value as incremented here, is less than my array length. Yes, it's less than, so now here will be 1 and will be equal to 1, and then it will again increment it, so now the range has 2 value. Like this it will run 4 times, and when the range value becomes equal to this my array length, so the loop will terminate it itself. And that was all I have done in this. So let's compile it, and there is an error just because we cannot specify the loops directly in the contract. For that we have to create a separate function and then we have to compile it. Simple, cut this. I will create a function for that. Function run loop, this will be of public, and simply paste this loop inside this, and again Ctrl S to compile, and that's correct. Go and deploy, check the second instance, and now we have 3 getter methods. First is of run loop, my array, and the third is range. First let's check the range. We have 0 range because we just call this getter method. By default it's 0 and we have not called the run loop yet, so obviously it will be 0. And my array, when I check on 0 it is 0, on 1 it is 0. When I press this run loop and again check the value, on 1 it's 1, and when I check on 2 it's 2, and on 3 it's 3, just like this. And when I check the range, now it has 4 range, and this condition will be same for the all loops. This was our while loop. Let's copy this and comment this out. We will create another function, run for loop public for. To create for loop we have a keyword for, and here we will simply say uint I equal to range, then range is less than my array dot length and I plus plus. That is the syntax for the for loop, and in its body we will paste this condition like my array set the index which is on the range, and that will be equal to the range, and again we will increment this range. Just like this, press Ctrl S and close these 2 contracts and deploy another one, and now we have run for loop. It has 0 value, and obviously when we check on 2 it has 0. Run for loop and again check on 2 we have 2 value. Check it and we have 4, just like this. And the do while loop is very easy. The difference between while loop and do while loop is that in while loop, if you can see, we check the condition and then we do the stuff we want, while in the case of do while loop we will do this stuff first and then we will check the condition. As simple as that. So let's comment it out, uncomment this one, and let me cut it, remove this while loop, do. In the body I will paste this, and then while I will check that condition, range less than my array dot length, and put semicolon. Again press Ctrl S, close this one, deploy and check 0 and 2 it's 0. Again check, on 2 we have 2 and we got the for range. That's how we work with loops in our Solidity programming language. Hi tech family, welcome to the part 14 of Solidity programming language course. And this time we will learn what are conditional statements in Solidity programming language, and we will also see how can we work with them. So let's move to the Remix IDE, and initially we have a file and identifier and the version of compiler, contract, learn, conditions, and that's our contract. And now let's start working with conditions. I will create two state variables. First, total marks will be equal to 1100 and passing marks will be equal to 500. It will also be of type uint, and then I will create a function check condition. It will take a parameter of type uint, obtain marks. This condition will be public view because we will read the state variables, and will returns the string memory because we will return a string message when we check the condition. And here we will create a string memory result variable, a local variable of string, and we will start checking the condition. If obtain marks are greater than passing marks, so we will return result which will be equal to congrats, you have passed the exam. And in the else condition we will return result which will be equal to string you are failed, go and meet your father at home. Just like this. Let's compile the code, and we have an error. Let's see. Parser error, expected semicolon but got function. Okay, I forgot the semicolon here. Again press Ctrl S and deploy our contract. Okay, let's also make these two variables public, and again Ctrl S, deploy. Check the second instance. Our passing marks are 500 and total marks are 1100. And now I will pass my obtained marks, like how much marks I get in the exam. So then this function will tell me I am passed in the exam or not. Let's say I got 400 marks in my exam. Check condition, you are failed, go and meet your father at home. And when I say I got 600 marks, congrats, you are passed the exam. Now this condition was true and this was false. Like this, we can work with conditional statements in our Solidity programming language. Hi tech family, welcome to the part 15 of Solidity programming language course. And now we will learn what is bool data type or Boolean data type. And we will also see how can we use it in the Solidity. Without wasting our time, let's move to the Remix IDE. I have created a file and I have specified the license identifier and the compiler version, and I also have created a contract. Now we will start working with the bool data type or Boolean data type. First we will create a state variable which will be of type bool. Its name will be checker and its visibility will be public, and that's how we declare a variable of type bool. Bool is simply nothing but it has values of true and false. Like we can initialize it true or false. Just like this, it has only two values. To understand it more deeply, I will create a function. Its name will be is bulb, and in the parentheses I will pass uint heat, and I will make this public, and also its return type will be like returns bool. It will return the bool value true or false, and then we will check the condition. If heat is greater than 100, we will return false, that off the bulb. In the else condition, we will return true. If the heat was greater than 100, so the bulb will off automatically. It will become false, and if it was not, so it will return true. Just like this, press Ctrl S to compile and move to our deploy and run transactions. Deploy our contract, open this instance, and we have two fields. Check this. We have false value by default because we have not initialized it, and now we have to pass some value in here. Let's say I pass 50. I press this is bulb, it returns nothing just because it will not like this. If the heat was greater than 100, I have to set the checker equal to false and then return that checker. just like this. And in the else condition, I will paste this, otherwise it will be true, and then we will again return the checker and close this one, press Ctrl S, deploy another one, and now first check it, we have false when we pass 50 value, and again check it, it's true. Now it's true because the heat is less than 100, and if I pass the heat 122 and again check it, now it's false. As simple as that, we can work with our bool data type or boolean data type. It will be true or false, just like this. Hi Tech family, welcome to the part 16 of Solidity programming language course. And now let's learn what is struct or the structure data type in Solidity. And we will see how can we use it in the Solidity. We have seen many data types in the Solidity programming language like int data type, string data type, boolean data type, and many more. But that struct or structure is a complex data type. It is something like the collection of the built-in data types integer, string, and boolean. Or we can say it is made up of these built-in data types, or that will be included in that complex structure data type. Let's see how can we work with this struct or structure data type. Move to our Remix IDE. We have specified the identifier and the compiler version. And first thing you have to know about the struct data type, we also can initialize this struct data type outside the contract and also inside the contract. If we initialize it outside the contract, so we are able to use it in our alt smart contracts, like in one file we can have many contracts in place. If we use it outside, so it will allow us to use it in the alt contract. But if we initialize it inside a particular contract, so it will not allow us to use it in the other contracts are present in this particular file. So we will create the struct data type outside the contract. To create that struct data type, there is a keyword in the Solidity, struct, and then we will specify its name. Let's say an employee, and in its body there we will have many built-in data types, like an employee has its name, its biodata, its skills. Just like this, we can have many types. So first we will have the employee name, which will be of type string name, and his skills, his salary, it will be of type integer, and I think that's enough. That's how we can create our structure data type or struct data type. Now we will create our contract. The contract name will be, let's say, my contract. And you know how can we declare a variable in our Solidity. It is statically typed language, so first we have to specify its type like uint number, and that's how we declare our variable. Just like this, we have created our complex data type of named employee. So instead of that uint, we will pass employee. Now that's our data type, and its name will be emp, and we will also make it public, just like this. And now we will initialize these subdata types name, skills, and salary in our constructor. Let's see how can we do that. Constructor, here I will pass string memory name, string memory skills, and int salary. And inside this constructor body we will initialize our substruct data types. So emp dot name will be equal to that name, and emp dot skills will be equal to these skills, and emp salary will be equal to that particular salary. And after that, press Ctrl S to compile and deploy. It's not deployed just because whenever we pass some parameters in our constructor, we have to specify these parameters in here, and then it will let us to deploy. So the name will be John, and the skills will be 9 years. It's not asking for experience but skills. Okay, let's say blockchain developer, and salary is 9, that much salary. Deploy, and we got our contract. When I press this emp, you can see we got the name is John and the skill is blockchain developer, and salary is that much salary we have specified in here. That's how we can initialize our structure subdata types in our constructor. What if in case we want to change these substruct data types using a function? How can we do that? For that, we have to create a function change employee data, and same as this constructor, it will also take these parameters. I will copy and paste it in here. This will be public. Create a variable of type employee because that's our complex data type which has many sub data types. So that struct data types use storage in our smart contract. To use that in our function, just like the string variable, if you remember, we also have to put the memory here to use it inside a function, and then we will specify its name. Let's say empl equal to employee, and then inside these brackets we will set that name will be name and skills will be skills and salary will be salary. And at last we will do emp that stat variable will be equal to empl, and just like this we have created our function to change our data. And then press Ctrl S to compile, and we got an error. Let's check it. It says I have to put the semicolon here, and also you remove this comma, and that's it. We are all set and the contract is compiled. Go close this one, and now I have to specify the name of our employee. So let's say the name will be different this time. The name will be Lee, and his skills will be designer, and his salary will be, let's say, 80,000. Deploy, and we got the second instance. When we check it, we got the name Lee, skills designer, salary 80,000. And to change them, we will again have to specify the name, and this will be also a different name. Let's say Harry, he is a architect and his salary is that much. Change it, and if I again check, we got Harry, architect, and that much salary. That's how we also can change the structure subdata types through a function or using a function. I know it was a little bit hard for today, but you have to understand these things, and I hope I have cleared your confusions about the struct data type. Hi Tech family, welcome to the part 17 of Solidity programming language course. And now we will learn what is enum in Solidity. Enum is basically a way to create user-defined data types. It is used to provide names to the integral constant to make the contract better for maintenance and reading. It will be some confusion in starting about this enum, so when you start working with this enum in the Remix IDE, it will become more clear to you. So let's move to our Remix IDE. Like always, we have these three things in place: identifier, version, and a contract. Inside this contract, we will create an enum, just like we have created a struct type. If you have not watched the previous video, I will recommend please go and check it out. We will create an enum and we will specify the name of the enum. Let's say status and curly braces. Here we will have some values like pending, accepted, rejected. We have these three values in place, but it will be still confusion why we have these three values in enum. What's the benefit of this? Why we have these values in enum? Just to make it more clear to you, now we have to create a state variable for that, as we have created for the structure or struct. So that will be of type status, name will be s1, and it will be public. Press Ctrl S, remove the comma from here, again press Ctrl S, we are all set, and go to deployer and transaction, deploy, check this first instance. When I press this S1, we got the 0 value, just because, as I said, the enums are used to provide the names to the integral constant. So this name is 0, and we have provided it a name which is pending, and that accepted is 1, and that rejected is 2. Just like this, we have provided names to these integral constants, and here we will create two functions to get these enums and set the enums to make them more clear to you. I will create a get function, or let's say first create a set function setter, and it will take a value which will be of status, and it will be public. In the body I will simply say s1 equal to status, and just like this press Ctrl S to compile, close this one and deploy another contract. Now we have a setter method. Check it, we have 0. When I set this enum, you can see it requires the uint8 value. I want to set 2 and set it. Now again get this, we got the 2 value. We already have the getter method created just because of this public, and if you want to create it by yourself, so you have to create a function getter, and this will be public view returns status, and this will return the s1. Just like this, press Ctrl S, close this one, deploy another one, and now we have also a getter method. Get it, we have 0, and in this getter method we also have 0, and when I set it to 1, set it, check this one, 1, and here we also have 1. As simple as that, we can work with our enums, and that enums are very useful to avoid some bugs in your project. And like this we can provide names to our integral constants or integer constants. Hi tech family, welcome to the part 18 of Solidity programming language course, and let's learn what is mapping in Solidity. If you have the background of any other programming languages, you may be familiar with the concept of dictionary. It is similar to that. The value stored in the mapping is in the form of key and value pairs. The key will be any built-in type of Solidity and the value will be of any type. If you don't have the background of any other programming languages, it will be a little bit confusion for you. But when we go dive deep in this mapping of Solidity, like when we start coding in Remix IDE, it will become more clear to you. So stick with us, it's not that much hard. The syntax of mapping look like this. We have a keyword mapping and the key type and the value type, and then we have to specify the visibility and the name of our mapping. To understand it practically, let's move to the Remix IDE. Like always, we have the SPDX license identifier and the version of compiler and a contract in place. To create a map, the Solidity provides us a keyword which is mapping, and as you have seen in the syntax, we have to put parentheses and then not the real key value pairs but their types. Let's say the type of our key will be of uint, and then the value will be of type string, and then we will specify the visibility public, and the name of the map will be, let's say, my data. Put semicolon, press Ctrl S, we are all set, and then move to the deploy and run transaction. Deploy, check the first instance, we got the my data and a field in front of it. When we type 0, we got 0 and a string. On 0 key, we have a value string, but for now it's empty because there is no data on it. You may be thinking it's something look like the array, like on index we have values, but in case of mapping we have keys and values. I will also clear that confusion later in this video, but first let's focus on these basic steps of mapping. Now to insert some data in this mapping my data, for that we will create a function like always, that will be a setter function. It will take 2 parameters. The key will be of type uint key and the value will be of type string and value, and we will make its visibility public. Open body, my data key equal to value, same as we did in the arrays, but there is a huge difference in mapping and arrays. It will be clear to you in a while. Okay, so press Ctrl S, we got an error just because we also have to put memory here in front of string. Press Ctrl S, we are all set, and close this one, deploy another contract. Now we have 2 methods in place. On 0 we got 0 and string as we get previously. So now we will set some value in here. Let's say I want to set some value on 5 key. the key will be 5 and the value will be, let's say, John. Set it. When I check the 5, we got the John value. Just like this, we can insert some value on our particular key. And if I want to set some value on key 3, that will be okay, and set it. When we check 3, we got that particular value. To dive more deep in it, we will use the struct complex data type so that it will become more clear to you. So inside the contract, I will create a struct. If you are new to this channel and watching this video, and if you don't know what is struct, so I will recommend, please check out the channel. You will find the video of struct data type. First watch it and then come here, so it will be more clear to you how can we work with this struct. Now we will specify the name of the struct. Let's say employee, and its subtypes will be string name and string skills. And instead of this string, now we will put this employee. Now we have that complex data type, and in here I also have to increase these values. That's our key, and this will be name, and we will create another parameter string memory skills, just like this. And the next thing we have to do it in here, we have to remove that value and put employee, and inside its parentheses we will specify the name we have passed in the parameters and skills, just like this. Press Ctrl S, close this instance, deploy another one. First let's check on 5, we have name and skills. Just because you can see instead of a simple string, we have now a complex data type. It has sub data types of name and skill. That's because we have got name and skills and that are empty. Now we will set some value in here, then we will check on 5. I will set some value or a name of employee, that will be Steve, and he is a blockchain developer. I will set it, and then again check this 5. We got the name Steve and the blockchain developer. Just like this, we also can use the struct in here in the mapping, and then we can insert the data in it. I have told you a couple of minutes before, we will understand the difference between mapping and the arrays. So let's move to an PPT, and then we will start understanding the difference between array and a map. You will see a table on the screen. That's mapping and that's the array. In the mapping, we have keys of 100 and 150 and the values are same, but in case of array we have index instead of key, 0, 1, 2 and John, Steve and Joy, just like the mapping. But the thing you have missed in here to notice, we have 100 and 150 and in here 0, 1, 2. Why is that? That's because let's say the key of that Steve is 100. We only can access to the Steve when we use the key of 100. So if you have seen, when we deploy the contract, if I set the value of Steve on 100, so we can only access the Steve on the 100 key. But if you see the array, we have the 1 value in the sequence 0, 1 and 2 and 3, 4 and so on. But in mapping, we have not any sequence. We can specify any value on any key, and the key will be of built-in type and the value will be of any type. But the array is in the sequence 0, 1 and 2. Let's say the Steve is on 100 and it's inside an array. So to create an array of 100 indexes, we have to create an fixed array of 100 indexes. You can see on the screen just like this, and then you will set some value on that 100 index. Let's say you will set the Steve, but the values coming before the 100 like 0, 1, 2, 3, 4, all the values before the 100 will be useless and they will take many space in the contract, just because the value we want to access is Steve and is on 100 index and it's an array. But the mapping make it easy for us. We want to set an value on 100, we can easily set the key of 100 and then the Steve. Just like this we can set in the mapping. That was the difference between the mapping and the array. I hope I have cleared your confusions about this mapping and array. Hi tech family, welcome to the part 19 of Solidity programming language course. And now we are gonna learn what are the visibility modifiers in Solidity programming language. So basically we have four types of visibility modifiers in Solidity programming language, that are public, private, internal and external. And we are gonna learn them one by one in this video. So first let's move to the public slide. It has 4 steps in place, and I think you maybe know this public modifier better than me, because in this whole course the most used modifier is that public, but we will still learn it just for those people who are new to this video. The first step is we can use it everywhere. What it means? Simply it covers these 3 steps also inside the contract, deriving contract and also the other contract. First we will see the second step inside the contract, how we can use this public modifier with a function inside the contract. For that we have to move to the Remix IDE. In the first step all the things are in their place, and we got a function here named public function, public, and that's the pair function because it's not gonna make any changes in the state variables and we don't have a state variables in place. Its return type is string memory and it's returning public. So first let's press Ctrl S to compile and deploy this contract. Check it, when I press this we got the public value and that's working fine. Now we will see how we can call this public function inside the contract. So for that I will create a string variable that will be public. Its name will be, let's say, pub equal to public function, and put parentheses in here. Press Ctrl S, we are all set, and let's move to, and okay, we are already in the deploy and run transaction. Let's close this one, deploy another one, and when I check it we got the pub and the public, and they both gonna have the same answer, public and the public. That's how we use this public function inside the contract, or the public modifier inside the contract. So that was our first step. And the second step is deriving contract. So what does it mean? It means, if you know the concept of object oriented programming, you may be familiar with that. There is a concept of inheritance in the object oriented programming. Like in the other programming languages, we simply inherit one class with another class, but in case of Solidity we don't have any classes but the contracts. So we will inherit the second contract from this first contract. So let's see how we can do it in the Solidity programming language. We will create another contract and its name will be second. To inherit it, there is a keyword in Solidity, we have to put it is, and then the name of our contract, initial contract, and then now it's inherited from this initial contract. So nothing have to do in here. Press Ctrl S and close this contract, deploy. Oh, we don't have to deploy this, but you can see in here you have to select this second contract and then again have to deploy and check the fourth instance. We again got the pub and the public function just because we have simply inherit the second contract from this initial contract, and then we got these two functions because when we inherited, all the properties of this first contract will be inside the second contract. Just because of that inheritance, when we check it, we got the same value like previous, and that was the meaning of that deriving contract, like the inherited contracts, we can say that. And then the next is other contract. So now what it means? It means not the deriving contract, like we don't have to inherit it anymore and close this. We simply have to do is create an object for that. If you know the object oriented programming of any other programming languages, you maybe definitely know this concept of creating object of the classes, but this time you're going to create the object of the contract. So to create the object we have to put the initial contract because we are going to create the object for that class or that contract. Sorry about that, it's contract not the class, and we will put its name, let's say I equal to new initial contract, put parentheses, semicolon, and we got the object. Now we have to use it. After that I will create a variable string that will be public. Let's say s1 equal to, or not s1 but call equal to, because we are calling the function, so that's why I put the name call equal to I dot public function, put again parenthesis, semicolon, and like this we can call the functions of the other contract in this separate contract. So now when I press Ctrl S, it does not throw any error. So when I close this and deploy this second contract, you can see here, and check this fifth instance, we got the call. When I press it, we got the public value, this public value, just like this. So that's why I wrote in the first we can use it everywhere. That was our public visibility. And the second visibility we have in the Solidity programming language, private, the private visibility. So let's see the first step. We only can use it inside the contract where it's placed. What it means, neither derived or not the other contracts. Okay, let's see what it means. Again, move to our Remix IDE. Okay, let's convert this public into private, and this will be a paper. Okay, and also let's change the name of this function, public, and also change this text and this one. Okay, first let's comment it out because we are going to check this inside the contract first. And when I press Ctrl S, and we are all set, just because we are calling the private function inside the contract. So as I said in here, we only can use it inside the contract where it's placed, and it's placed inside the contract and we are calling it, and that's great. When I press Ctrl S, and okay, let's close this all contracts to make it more clear to you. Inside the contract, when I deploy it and call it pub, okay, and we got the private value. Just like this, we can call it inside the function because that's private. And let's also check we can call it in the separate contract or the other contract. We have to call this private function, and that's correct. When I press Ctrl S, it throws an error just because, as I said, we cannot call the private function in the separate or the other contracts. When I check this error, let's see, private function not found or the visible after argument dependent lookup in the contract. It's simply saying we cannot call the private function in the other contracts. Okay, let's also see how we cannot call the private function inside the derived contract. So let's inherit this second contract with the first contract is initial contract and try to call it. Let's uncomment this line and remove this I. Again, when I press Ctrl S, we got the undeclared identifier error, and we also cannot call the private function inside the deriving contracts or the contract inherited from this first contract. And that was for the private. And the next modifier we have is internal. So let's see what it says. We can use it inside the contract. Okay, we can use it inside the contract, also deriving contract. Okay, when we inherit the second contract from the first contract, we also can use it inside this. But the third step is not inside the other contracts, where you cannot call the function with the internal visibility or the modifier in the other contracts. So let's prove it. Move to the Remix IDE and change this private to internal, and also change these names. Comment this out. First we will check this internal modifier inside the contract. Can we call it inside the contract or not? When you press Ctrl S and go to deploy and run transaction, delete this one, deploy, and check this first instance, and that's correct. We can call it. We got the internal string. And let's also check it for the deriving contracts. Let's uncomment this and also change the name of this function, internal function. Press Ctrl S. It didn't throw any error just because we can call the function with the internal modifier in the deriving contracts. So it didn't throw any error. Close this one. And now I have to deploy this second contract. Deploy. Inside this you will see two functions, pub and the call, just because this pub is just because of we have inherited, and we got this also inside this second contract, and the call is also here. When we press this call, we got the internal. When we press this pub, we got the internal value. So like this, we can call the function with the internal modifier inside the deriving contracts. So let's also check it for the other contracts. I have to comment this for now and remove this. Now it's second contract. Now I have to uncomment these two lines, and there will be I dot internal function. Let me show you again. Not in the other contracts. We cannot call the function with the internal modifier in the other contracts. Okay, let's check it. When I press Ctrl S, oh, we got an error. Just because I told you we cannot do this with the internal modifier. Okay, that was our internal modifier, and the next last is external modifier. Let's also check its steps: deriving contract, other contracts, but not inside the contract. What does it mean? It will be clear to you in a while. Let's move to the Remix IDE and change these internal to external, and also change these names and comment this out for now, because first we will check inside the contract. When I press Ctrl S, we got an error. The third step is confirmed, if you see, but not inside the contract. And now we will also see these two steps just for the confirmation, and let's comment this out because this will throw an error and it will not let us to know about also these two steps. So let's comment this and uncomment this. First we will check the other contract. So let's change its name, copy this and paste it here. When I press Ctrl S and it's correct, we can call the external function in the other contract. So when I check and close these, deploy the second contract, you can see we have deployed the second contract. Check this instance. When I press this call, we got the external value from this function. And now let's also check it for the deriving contract. So we have to put is initial contract, and that's it. Press Ctrl S and that's good. When I go to the deploy and run transactions, close this, deploy another one, you can see we got the external function and the call function. When you press this call, we got the external value again, and when I press this external function, that function, and we got the external value. And that's in the second contract, just because we have do inheritance in here. And that was some important visibilities you have to know about this when you want to become a blockchain developer and want to learn Solidity programming language. I hope I have cleared your confusions about these visibility modifiers. Hi tech family, welcome to the part 20 of Solidity programming language course. That will be the last video of this tutorial, and after that we will create a whole project in Solidity. But there are some important steps you need to understand. So now we will see what is payable in Solidity. When we write smart contracts in Solidity programming language, we need to ensure that the money is being sent to the contract balance or outside the contract. To make a function that will receive some ethers, we simply have to put the payable modifier for that. It will be clear to you when we move to our Remix IDE. In this video, we will also transfer the balance between different accounts. So let's see how we will do this. We are on our Remix IDE and all the things are on their place. So here we will create a function deposit. Its visibility will be public and payable. Just like this, we have created a function and we will not do anything in its body. That function can receive some payments to the account that will be stored in the contract balance. So through this function, we will transfer some ethers to this contract balance and we will then get it simply. Now we will create a function to get the balance function, get bal, and then this will be public view, because we are not doing any changes in the state variable. So this will be view, and returns uint, because that the ether will be of uint type, and return. The thing we are doing in here will be a little bit different. To get the balance of our contract, we will simply have to do address, and address is a special data type that holds the 20 byte values and provides built-in functions like transfer and balance, and every account and the smart contract is represented with the unique address, and then parentheses and this dot balance, just like this, that this here means the balance of this particular address. We are getting the balance of the contract, so that will be the balance of that particular contract. So now I will press Ctrl S, it's compiled. When I deploy it, we have two functions here. When I get balance, for now we have 0 balance in our contract. When I press deposit and again check it, we still have 0. Why is that? Just because we have not passed any value to transfer in the contract balance. So first we have to specify some value in here that we want to transfer to our contract balance. So I want to transfer, let's say, 3 ethers to the contract balance from that particular account, and that value unit will be ether because I want to send 3 ethers. After that selection, I will press this deposit, and you can see when I resize this terminal, that much transaction is done to the contract balance. That 00 is just because it's in the form of way, you can see here. And when I press the get balance, we got the 3 ether in the form of way unit. Just like this, using this payable keyword, we can make a function payable that will receive some ethers or money. And we have talked about in starting, we will do transaction between different accounts. So we have these fake accounts and fake ethers in place. We will do some transaction between these accounts, and you can see the balance is now 96 because we have transferred some balance to our contract balance. To do transaction between different accounts, now we have to create a variable of type address, and this will be payable, let's say honor equal to payable, and then some address here. I want to send some ether to that account 0xab and 8. I will select this and copy its address, paste it here, put semicolon here, and then close this. Now we will write a function to transfer some balance to that particular account. I will write a function send balance, or we can say send ether, and its visibility will be public. And the thing we have to do is honor dot transfer to ether. I want to transfer to ether to that particular account. So I will select another account, let's say select this first one, and from this first account we will transfer 2 ethers to this account AB8, this account AB835CB2. And you can see we use the transfer here just because of this address provide us the transfer and the balance built-in functions. So after that, Ctrl S to compile and then deploy the contract. In the second instance, we have three functions in place. When I get the balance, we have 0, and now I want to transfer 5 ethers to the contract balance. Deposit, 5 ethers are transferred in the form of way. When I check it, we have the 5 ethers, and now I want to send 2 ethers through this function. So when I press this, when I again get the balance, now we have 3 ethers. And when I check out the account AB835, that account we have specified here has 102 ether because we have transferred 2 ether from this first account. Just like this, we can work with the payable keyword and do transaction between different accounts. And now it's time to create a whole project in Solidity programming language. Hi tech family, welcome to the another part of Solidity programming language course, and this is not the part of the course but the application on that combinations of what we have learned in the previous series. So in this video we are gonna create the lottery app, combine all the knowledge we have learned in the previous videos, and move to the next slide. They are the topics we have to cover in this video. Deploy our contract on the Ethereum blockchain. In the previous videos we have covered many topics, and in those videos we have just deploy our contracts on the JavaScript virtual machine. But in this video, first we will deploy it on our JavaScript virtual machine, and after that we will deploy our project or our smart contract on the Ethereum blockchain. I will show you practically in this video how we will do this. And the next is MetaMask. MetaMask is cryptocurrency wallet where we store our cryptocurrencies, and I have explained it in my video. If you didn't watch that video, I will give you a link in the top card corner of this video and you can check it out. So in this video it will be more clear to you how can we work and use the MetaMask. And the next is work on the testnet Ringb. Ringb is just the name of the test network, and we will work on that particular network, and that is the test network of the MetaMask. And these are the three topics we are going to cover in this video, and there are some things in our project I want to tell you before starting the project, so you will be more familiar with these and there will be no confusion for you that why that exists and why these things are happening. So in the third slide we have the heading. What we would have an owner of the lottery. He will manage everything, like to announce the result, who is the winner, and store the address of the participant, like that is now the participant of the lottery and he can get some prize after announcement of the lottery and all these things. And the second step is we would have players, and to announce the result of the lottery the players must be at least greater than or equal to 3. When the players are the less than 3, so the lottery will not be announced, or the owner will not do this, just because for that we must have 3 or greater than 3 players or the participants. And the first step is when we receive some amount from the player, we will register this particular address, and we will also see how we can do this. And we will generate the spin randomly, and one player will win and get all the ethers or the balance which are added to the lottery from these 3 or more than 3 participants or the players. That was some steps you must have to know before starting our project. So when we do things and when we try to do and create functions for that, so that will be more clear to you. And the last thing is when the person get his or her prize, then the lottery will be reset automatically. Not automatically, but for that we will write some code to reset our lottery after all. That was some introduction I want you to know to before starting the project. And I hope I have cleared all these basic steps for starting the project, and I hope everything will be cleared when we start coding in our Remix IDE. So after that, let's move to our Remix IDE, and again we are on our Remix IDE. We have a license identifier and the version of the compiler, and now we will start creating a contract. If you remember, I have told you in the introduction of this video, we are gonna have two things first in place, the owner and the players. So now we will create an owner. The owner will be of type address, and that will be public owner, and I will explain why this owner type is address in a while. And again we are gonna have address and then payable, because when the lottery is announced and after all one of the player will be winner, so after all there he will receive some ethers or some payment. That's why we have to make it payable, and that will be a dynamic array because we are gonna have many participants in place, and we will make its visibility public and name will be players. And just like this, that's our owner, and that will be our players who participates in the lottery. And after that there will be a constructor, and in here we will do owner equal to message dot sender. I know this thing will be new to you because I have not explained in this my video, but no worry, I will tell you in this video what this message.sender means. It simply means the sender of the message. Like now owner is the sender of the message. When we deploy our contract, so the address from which we have deployed our contract, now that will be the owner address. So when I press Ctrl S and go to this. Remember this address, we are gonna deploy our contract on this address 0xb3. And when I deploy, and just to show you, when we press this owner 0x5b3 and 0x5b3, now that's our the owner address. This message sender simply means just like this, that's our account, and on that particular account when we deploy our contract, so now that's the address of the owner. And the next thing we have to do is create a function to receive the balance from the participants or the players. So in Solidity there is a function like the constructor, a special function which is receive. You can see its color is changed to the pink color because that's the special function. And after that I will do external because that receive function will be external, and payable just because it will receive some payment, so that will be payable, and then just like this. And if you remember, I have told you when the player do some payment on or send some ethers or payment, so we have to register its address in our contract. So we will do it just like this. If you see, we have created a dynamic array, so we will do players dot push payable message dot sender. That will be a little bit confusing, but simply I have do players push. I have just push the address, and that is message dot sender, the sender of the message or the sender of the balance for now. Now that's not anymore the owner address, but that will be the sender of balance or a player who want to participate in the lottery. So like this we can register our player in our lottery, and after that I will press Ctrl S just to show you how we have register our player address, and then close this one, and you can see that's our owner. Okay, just remember this address, that's our owner. I deploy the contract on that particular address, so when I check the owner 0x5b3, that's our owner. And when I select the another account and want to do some transaction, so I will simply select 1000 here and transact. Some transaction is complete. You can see 999 way is transferred to the contract balance or the lottery. When I check here 0, we got the address. We can say we have registered our player, and that's the first player who do transaction of 999 way. And if I check, we can see now that's our user or a player. He do some transaction to the lottery and we got his address like this. And again if I do some transaction here, you can see here 200 and it's in the form of way. Okay, press this transact, and again on the one address, if I check it, we got the same address just because we have not select the other address for transaction. So now I will select this and do some transaction of 200 way and transact. And if I check one, not one but two, because we have do transaction on that account 2 times, when I check this, we got the third address, that address 0x4b2, and you can see 0x4b2. Just like this, we are registering our participants or the players who want to participate in the lottery. And next thing we have to do is to check the balance, how much balance we have now in the lottery or the contract balance. And I also have shown you this thing in the previous video, if you remember, the video of the payable or doing transaction between different accounts. So I will get a function for that. That will be a function of get balance. That will be public view returns uint, and then return address this dot balance. Just like this, we can get the balance of our contract, and that will be our lottery balance. Press Ctrl S, and I have to close these contracts just to make it more clear to you. And now I want this fourth account to be my owner 0x787 and deploy. Now that's our owner. Remember his address 0x787. And when I open this owner 0x787, that's our owner. When I check the balance, for now it's 0 just because no players has do participate in the lottery. So to do that, now I will select this 0x617 to participate as a player. 0x617, he will transfer 400 way transact, and when I check it on 0, we got the address 0x617 0x617 just like this. And when I check the balance, we got the 400 balance just like this. But if you have noticed, I checked the balance on the player's account. How player can check the balance? The player will not be able to check the balance, so only that owner 0x787 has to be right to check the balance, not the players. No random players will be able to check the balance. So for that, we have a built-in function in Solidity programming language, that is require. It's just like the if-else condition. Let me show you. Here we will check the condition require if message dot sender is equal to owner. If that condition was true, so then this will execute this return statement. Otherwise, this will throw this message or show this message: you are not the owner of the lottery. Now if I want to check the balance on the player account, so it will say you are not the owner of the lottery. For that, you have to be owner so that you will check the balance of the lottery just like this. And we also have to make some limit in here. Maybe I will copy this and paste it here, and now I will say message.value. Message.value is just when we send some value with the message, like when this message sender or the player want to send some value, how much value or payment that will be. So the value must be greater than or equal to 500 way. Otherwise, if the value or the payment was less than 500 way, so it will say you cannot participate with low balance, just like this. Now let's check this require statement just like the if statements. And when I press Ctrl S and go to the deploy run transaction, okay, we are already in, but we have wasted many ethers on the do transaction and it has charged many gas limits, so we are not able to see the clear 100 value. To make it more clear to you, so for that I will just restart this page and then again open our file and again compile it, and you can see now we have all the accounts resetted and all again got the 100 ethers. So when I press this 100 and deploy it, remember that will be our owner 0x5b3, and open this one and that's the owner. So we can get the balance of the owner. Obviously we can do this. When I press the get balance, yes, the owner can get the balance. And now let's try to transfer some balance from the player account. So that's our player 0xab8. Let's transact some 400. Remember, this statement require value must be greater than or equal to 500 way, and that's 400. Let's check it will throw an error or not, or a message. Sorry about that, a message, not the error. And when I press this transact and resize this, you can see here you cannot participate with the low balance and the transaction is revert. So we cannot participate with low balance in the lottery. For that we have at least 500 or greater than this way to participate. Now that's our player or participant. On the 600 value or way he can transact. Now the transaction is completed. You can see here check, green check here, and when I check the balance, again it says you are not owner of the lottery. Oh, I am not owner, so I will go to this account, switch account, and again check it, and so I can check. You can see we got the 600 way just because now I am the owner on that account, and on that account I cannot check. It will say you are not owner of the lottery. And just like this we can work with all these things. Let me again explain to you just for quick recap. That's our owner, address owner, and address payable, public players, and constructor. We have initialized the owner will be the message sender on when we deploy our contract. So on which address we have deployed our contract, that will be our owner. On the receive, that's external and payable, has to receive some balance from the participants who want to participate and require the value will be greater than or equal to 500 way, and if it was not and this condition was not true, so it will say you cannot participate with low balance, just like this. And that's the simple get function and just view function, because we are not making any changes in the state variables. And this is some code for now we have done, and I will see you after a little break. Hi, I am back, and the next thing we have to do is in here to generate a random number. So for that I again have to write a function, and this will be random, and this will be public view returns uint. And then to generate some random numbers we have that algorithm. If you don't know about this, you have to do some searching. The kickcake 256 is a cryptographic function built into Solidity. This function takes any input of type uint and converts it into a unique 34-byte hash. That's our kickcake 256 hash. And then we have to do abi.encode packed. And if you don't know about this, you have to do a little bit searching. It doesn't take any fees from you. You have to search. It's not that much hard. You can learn it easily. And abi.encode packed. Inside this we will do block.difficulty, the current difficulty of block. Let me show you all the units. You can see the message sender. I have told you message, the sender of the message or the current call, and the message value, the number of the way or the amount sent with the message. And we have done it in here. You can see the value and the message sender, and the block difficulty is the current block difficulty. And we will also use the current block timestamp as second since Unix epoch. So we will do block.timestamp and again players.length, just like this. And its return type is uint, and it do not return the uint, so we have to do typecasting uint and just wrap these in the uint and press Ctrl S, close this one, and that's our owner, the first one. Deploy and check it. The random we got 0. Why is that happening? Let me check. Okay, that's returns, and we don't return it just because it's not showing anything. And just like this, press again Ctrl S, we are all set, and close this. That's owner. Deploy, and when I press this random, and yes, we got the value, and press it again, and we are getting the random values. Here I have to tell you one more thing. You have to be careful when creating these random functions because they are at high risk. That's just for testing. I am creating these random numbers and generating these random numbers on that kitcheck 256 hash AVI encode packed. But you have to be careful. In that case, we have many algorithms for that to create the or generate the random numbers, so you have to be careful, and please don't deploy this contract on the mainnet just because it can cause some problems. I'm showing you just for the testing purpose, and you have to be careful, I would say that. If I show you why is that in risk, when I press this, you can see sometimes it not change. You can see I pressed again and this code didn't change, just because they are a little bit in risk. You don't have to deploy it on your mainnet. That's just for testing purpose, for generating the random numbers. We have many other algorithms for that, so I would again say be careful when generating these random numbers. And then again we got the randoms, and after that I have to convert these random numbers to the index, and we will do this stuff in the function of announcement of the winner function, and that will be announce winner. For now that will be public view returns address, just because for now we will return an address of the winner, who is the winner. And then we also need some conditions here. I will copy this and paste it here, like only owner can announce the winner. So I will say message dot sender is equal to owner, so it will announce the winner. Otherwise it will say you are not owner of the lottery. And again, next condition we need is players dot length must be greater than or equal to 3. If it was less than 3, so it will say this message players must be at least 3 or greater, just like this. And then we will create an variable address payable winner. The payable is just because at last we will pay all the payments inside the lottery to that winner. That's why it's payable. He will receive some payment. That's because it's payable. And then we will call the random function. Its return type is event, so we will do event call random equal to random, just like this. Now we will convert these numbers to index. So for that we have to do event index equal to call random modulus players dot length. Just like this we are converting it to index. Let me show you what that modulus means. We will go to this in here and inspect that. And I know that environment will be a little bit weird for you if you are not a web developer. You can see these things, but we are not going to do anything here. We will simply go to the console just to show you the modulus and zoom it a little bit. Let's do some random number, and there was player length, so let me do, we have 6 players in place and we got the 5 value. And there is an interesting thing, let me tell you. No matter how much that value is long, but we are doing this modulus and 6, the result will always be less than this 6. So it means it starts from 0, 0, 1, 2, 3, 4 and 5. Just like this we are getting the random numbers. It will be a little bit confusing, so let me show you practically. We have that random number. I will copy it and go to here. I will paste it. That's our huge big random number. To convert it into a random index, so we will modulus it. And if you see the player's length, so for let's say we have the 3 length and the random index is 1, but it will not be greater than 3. It will be 0, 1 and 2, but will never be greater than 3. And if I show you how it's random, let me decrease some values. you can see it's become 0, and when I decrease some more it becomes 2, and when I again decrease it's 1 and 2, 0 2, 0 1 2 and 0 1 2, just like this. It's decreasing, but it will never be greater than 3, and it will give us the random index 0 1 and 2 which are less than this number, or the length of the players who are participating in the lottery. Just like this, we are getting random numbers through this. And as we have got the random number, after this I have to do winner the address equal to players of index and simply return the winner address. After that I will press Ctrl S and we are all set. There is no error. Close this instance and okay, let's also reload the page to reset all these ethers from here, and that's our contract. Deploy it again or compile it, sorry, and then we got all the ethers again, and that's our owner. On that I will deploy, and if I check it again, these are the random numbers and we are not gonna touch it anymore. Now we will do some test in here. After that we will deploy this contract on the Ethereum blockchain, and one thing is also remaining at last. Here we will do the thing to transfer all the ethers in the lottery to the winner address, and we are just returning it for now, and after that we will do this transaction also. So I will select this, remember this account, that's our player. He will transact 7, let's say 1000 way, transact, it's done. And from this account third I will do, he will also transact 1000, and from this, okay, just for a little bit testing, when I go to this owner and press this announce balance, at this condition becomes true, players must be at least 3 or greater. Now this conditions become false and this show this message. And now again do select this third participant or player and transact 1000 way, transact, and again go to the owner and get the balance. We have 3000 balance from the 3 players, and now we will be able to get the winner, and that will be on the random index when I press this winner. So that's our winner, we got the winner address, but we are not transferring any balance to that particular account. We will do it in a while. To do that, we have to remove these returns because we are not going to return it anymore. And then winner, if you remember, I have told you winner the address give us the transfer and the balance built-in methods dot transfer, and we will do in here get balance, just like this. And that was it. Press Ctrl S, close this instance and deploy. Okay, that are become again this, so now I again have to reload it. You don't have to do it on this, but I'm just doing it for testing purpose, so I want these ethers to be 100 to make it more clear to you. In the contracts I will compile it first and deploy. That's our first owner. Get balance, for now it's 0. Now this participant will do transaction. Now you have to remember their ethers also, just because when the owner announced the lottery, so after all you will see the winner will have more ethers in place. So let's see how he will do this. 100 ethers, and he will transact, let's say 5000 way, transact, and then that second will also do 5000 way, transact, and then this third will also 5000 way, transact. And let's remember these 3 balances, they have ethers, and when the owner announces the balance, you will see the one will have more ethers than the remaining two. So I will switch to the owner, announce balance, and you can see here the third is the winner. He has 100 ethers again and some more ethers if you see here, and all the balance inside the lottery is transferred to his account, and he is the winner. And our code is ready, and the thing we have to do it in here is just to reset our lottery when the result is announced. So in the last I will do players equal to new address payable 0, and just like this, when on this line of code it will reset a lottery after the announcement. Just for the checking purpose, I will do again this stuff, press Ctrl S, close this instance, and also reload this, compile, and when I deploy it, that's our owner first 0x5b3, and let's just do transaction of from this account second 5000 way, transact from this third account 5000 way, transact, and from this third account again 5000 way, transact, and switch to the owner, and let's get the balance. We have that much balance. A little balance is low just because I don't know what happens, the balance is low. Okay, just let's announce it and again check it. That third account 0x has a little bit more ether in place, and that's the winner. And if I again check on 0, we are getting nothing, just because at last we have done this code and it's clear after the announcement of the result. So I will see you after a little bit break, and then we will deploy our contract on the real Ethereum blockchain. Hi, I'm back, and the next thing we are gonna do is to deploy our smart contract or a lottery app on the Ethereum blockchain. So to do that, we have to go to deploy and run transaction, and from here you have to change this JavaScript virtual machine to the injected web3, and our MetaMask opens. And if you don't have any wallet for the MetaMask, I already have created a video and I have told you in the starting, go and check it out so that it will be easy for you. How can we deal with the MetaMask? Press, I already have a wallet for that, so I will unlock just, and it will take a while for unlocking, and it's done. You can see we are connected with the test network ring B. You can see here the ring B, and we have that much ethers. I will select my account 1, which has 0.788 and 9 ETH fake ethers, and there are some more activities. I have done transaction between accounts, so that is some activity showing up here just for the testing purposes. And now the next thing I'm gonna do is to deploy my contract through this account, and that will be my owner account, we can say, or yes, the owner account. Now I'm going to deploy this contract on this account. That will be our owner account. You can see it also here, 0xe72 and 0xe72. So I have to press this deploy, and this will charge some gas here. Press confirm, and after some time, it will take some while because it's doing on the Ethereum blockchain. So you can see it says confirm transaction. When you press this, it will send me the Etherscan, and here it's still pending, and after some time it will complete, and then it's success. it takes some time just because of it's doing on the real Ethereum blockchain. Again, move to our Remix IDE and we got our deployed contract, and it take few times as compared to previous, just because it was on our real Ethereum blockchain. So I will open this simply, and nothing we have to do it here, just because the transaction or the player sends some payment to the lottery or the contract balance will be done by the MetaMask. So if you see here, I have accounts, player 1, player 2 and player 3. If you want to create an account for you just like this, there is an option you can create your own account and take some fake ethers from the ring b faucet and gorilla faucet, and there are many faucets to take ethers. There are chain link also, and I have these players, and that is my owner account that will manage everything. So now I have to select this, or let's just move to the MetaMask full window and also unlock it from here. The thing we have to do is here we have selected this player 1, and let's see how we can create account, just for if you're new here, to show you how can create account. So you have to press this create account, add the name of your account, let's say my SEC, and create it. Just like this you can create your account. This will take a while and it's done. We got our account by my SCCC. That's how we can create account. And if you want to get some ethers, fake ethers from the ringp network, I will share the links in my video description so you can get it from here. And the next okay, now let's select this player 1, and now I want to transfer some ether to the lottery. So I will press the send, and I want to paste my address here. So go to Remix IDE. So just you will see in the left corner there is the address of our contract. You have to copy this and just move to the MetaMask and paste it right here. And so now we will send 5,000 ethers in the form of way, just because we don't have much ethers. So you can see our current balance is that balance. Just remember this, or I will put the picture here right here, and you can compare it. So to send 5,000 ether in the form of way, so I have to do is go here. That's a website, ETH converter. So how many ethers are in the 5,000 way? Okay, we got it, and that much ethers are in the 5,000 way. I have to copy them, and in the MetaMask I will paste it right here, and next, and confirm. And it will take a little bit time, it's pending, you can see here. And it's done. Transaction 1 confirmed. On view on Etherscan, press it and it send us here. The transaction is completed, and the value you can see it here. We send that much ether to our contract balance, or we can say our lottery. And when I go to Remix IDE and switch to our admin and just check the balance, it takes some time, just because I have told you it's doing on the real Ethereum blockchain. We got the 5,000 way, and the next transaction will be done from the next player 2, just because when we announce the result, so obviously it will show that message players must be at least 3 or greater. So for that, now I will again do transaction, and if you see player 1, you can see some ETH is subtracted from it. And now I will do transaction from my second account, and let's also remember these ETH, so it will be easy for you who is the winner, who got at last ethers from the lottery. So I will simply press this send, And again I need the address of the contract. Copy this and paste it right here and go here, and we need that much value and paste it here. Press next, confirm, and pending. After some time, yeah, it's done. Take a little bit time. We can see it on Etherscan. Here is pending. It will be done in a while, and you also can see the value here. And let's just do transaction from the third account. Move to this third account. Here it's showing the fixed value, but when you see here, you can see from here you will got the actual value. It's really subtracted or not, you can see here, and also here you can see. And now let's just remember this value. Some value will be, or it will be minus from it. So now let's just press this send and paste your contract address and go here, copy also this and paste it right here. Next and confirm. Again, this will take some time, and it's also done. Let's again go to our Remix IDE, and from here let's move to the switch account to the account 1. That's our owner account, so that we will get the balance, and we got the 15,000 way. So after that, let me show you their accounts. Just remember these. I will also show their screenshot, then we will compare it easily. That's their remaining value or the ethers. So when I press the announce winner, so all these ethers, 15,000 ethers, not the ethers, sorry about that, that's the way, will be transferred to the winner account. So let me just do that. We are on the owner account, or yes, we are on the owner account. So now let's press this announce winner, and it's doing on the Ethereum blockchain. It will show us. I want to confirm that. For that, it will also charge some gas. You can see here it's showing the gas it will charge, so I will simply press this confirm, and after some time it will appear the snack bar and it's done. When I press this, and you can see here from the contract balance that much ether, that 15 0 point and many zeros and 15 ethers are transferred from this account, this contract balance, to this 0xb447, and that's one of our account who is the winner. And let me show you who is the winner by go to the MetaMask, and let's check it. Is that player 1 0x2d? No, it's 0xb47. And let's again check the player 2 0xdd4. No, and it's confirmed. Obviously the player 3 is the winner, 0xb47, and yeah, we got it. The player 3 is the winner. You can see that much ether, or in the form of way, is transferred to this account, and we have done it on the real Ethereum blockchain or using the MetaMask. And when you press this see more, and you will see the more result. You can see the function announce winner is just pressed, and then this happens. Okay, when I press this contract, and you can see 2 minutes before some transaction is done, and here you will see the 0 ethers are 0 ethers just because the value is here showing 0. And if you see here, transfer that much ether, it's very little value. The value is in the form of way just because that's not showing here. But some transaction is gone from the lottery to the winner wallet, and that's the winner. And we have done it on the Ethereum blockchain using the MetaMask. If I again check it, that was our transaction done before 3 minutes ago. Can go back, And if I move to the Remix IDE again, and let's check I am on the owner account, let's switch it, and again get the balance. We got the zero balance just because all the balance was present in the lottery are gone to the winner account, and he was the winner. And when I check players here on zero, we will get nothing just because there is no players. All the balance are transferred to the winner account and there are no more participants or the players in the lottery. And if you see here, we have transferred that much value. It's very low value. I have transferred to the winner account, and also in the remix ID I set the limit of 500. Wait, that's very low limit. I should have to set it on 1 ether. I set it like this just because of I checked many fusers just for the test ethers and they didn't provide that much ethers to work with that. If I show you Google and on Rinkby, you can see all the links here of the Rinkby fuset, and here are purple. I have checked them, but all of them providing 0.001 ether, which are with some providing 0.1, and our main fuset is Rinkby authenticated fuset, and it's offline for now, and it also not providing me that much ethers to do transaction here. But I hope I have cleared to you also through this small value of ethers, or we can say little ethers. It's not a full ether, but in the form of way, and it's not a full ether. You can see it, it's 0 and point that much value. Also through these little ethers I have cleared this to you, how can we create an application of lottery, and how to create all these functions, and also how to deploy it on the Ethereum blockchain, and how to work with the MetaMask, and also checking these transaction results and their values. I hope I have cleared all these things to you. So if you found this video helpful, hit thumb on a like button and leave a comment if something is not clear to you. And if you want more videos like and want me to show you many applications, many great applications like this, so let me know in the comment section. For now, goodbye, and I will see you in the next video.